So welcome to week number 9, and this time we will be visualizing our gates first, and then we will go into the mathematics. So this time we will be studying two gates, the S gate and the S-Dagger gate, and we will also visualize one identity related to these two gates. So let's just start. And again, both of these gates are the special cases for the phase gate. So we know that we will require header mart gate to see their effect. So let's just do that. Visualize it. And initially what you're seeing here is just the effect of the header mud, and we know that the gate will the state vector will come over here, and then we'll be able to see the effect that the S gate has. And if you want this tool for yourself, you should check out the first video in this playlist, which the visually understanding quantum computing playlist. And the first video will help you to get this tool for yourself. And now you can see the what you're seeing right now is the effect of the S gate. You can see letter S over here, and let's see what it does. So it is indeed applying rotation, and that is expected because it is the special case for phase gate. But let's see what's the angle for it. Okay, so it has stopped, and you can see that it has applied an angle of pi by 2. All right, so it's a special case for phase gate where lambda will be equal to pi by 2. So again, let's do the same thing for the S-Dagger gate and see what happens. Again, the first part is again the Hadamard gate. It will just come here, and then we'll see what's the effect of the S-Dagger gate. We are waiting. Yeah, it is touched here, and you can see it has changed its direction. So the S gate went into this direction towards the y-axis here, positive y-axis, and you can see the, the S-Dagger gate is making it go into the opposite direction, and that's what they are related to. All right, so the S and S-Dagger gates are kinds of opposites of each other, and the identity that you are about to visualize is that if you apply S and S-Dagger together, they will have no effect. They will cancel each other out. So now we will visualize it, and we will also see mathematically how it works. But before that, let's apply header mod, then S, then SD, and let's see what happens. So again, the first part is the boring part. Header mod will have its effect, and then the interesting part will come, that how things change. So if you are having any idea, just pause this video right now and try to guess what would happen. Will this state will just stop moving on X, or what will happen? Let's see. And now is the effect of S gate. So it is moving, and we saw it the previous time as well that it will just end over here, the Y here. And if you are now able to guess what would happen, you can still pause the video and just try to guess again. And now it is just here. Yes, now it has changed the direction. So by now I think it must be really clear to you that what would be the result of this visualization. And it will stop here, right? So you can see this just came a halt at this state, the plus gate state, and you can see that after applying header mart, the first operation, it ended up in this state, and even though we applied the other two gates, the S gate and the S-Dagger gate, it still ended up in the same state. So it just means that the S and S-Dagger gate together are just good as identity matrix, identity gate. And now we will get into the mathematics part. I'll show you the matrices that represent both of these gates, and we'll also try to mathematically work out how this identity works. All right, so let's get to that. So let's get the mathematics part. Let's first see the S gate. So symbolically, we just represent it with a S, and this is the matrix that represents the S gate. Again, as I just told you, S gate is a special case for phase gate, where the value for lambda is pi by 2, and you can see here we substituted I lambda equal to pi by 2 here in this matrix, and this gives us our matrix for the S gate, which is actually this what you see here in the blue color. And now let's get to the S-Dagger gate. So you can see the symbolically a little, you can see a little dagger here. It's not prime, it's a dagger, and that's where the name comes from, the S-Dagger gate. And if you talk about the matrix, it's just another special case for the phase gate, but the difference is that you have this minus pi by 2 here. Okay, so it was just pi by 2 for the S gate, but it's minus pi by 2 for the S-Dagger gate. Again, if you just solve it, what you get is this. So this is the matrix that actually represents the S-Dagger gate. And now let's quickly try to mathematically work out the identity that we have already visualized. So note that we will not work it out on the 0 cat and 1 cat, the S and S-Dagger gates, because both of them are just special cases for phase gate, and we already know that phase gate has no effect on the 0 cat and 1 cat. We have seen it so many times. We have also seen it for the Z gate. So this time we will just try to work it with identity. So you see here, so the S and S-Dagger gate, just substitute in the matrices. All right, nothing very complicated. And then again, just do a simple matrix multiplication, and what you get is this. And if you very carefully observe it, this is nothing but the identity matrix. So it's clear that when you apply this S and S-Dagger together, their effect is just as good as the identity, which is no effect at all. So we have already visualized the identity, and we have also seen it mathematically. So now in the next week, I want to tell you that we will be again visualizing one identity, but it's much more complex than this one. And I will also visualize two gates, and we will learn about them next time. And until then, take care.